Hello everyone, welcome you back for the discussions on the seal. Now here the seals are used to avoid the leakages, the first and foremost application. The second one is for the smooth and also the wear free operation. Now especially in the case of the pneumatic systems, the seal and as well as the sealant materials plays a major role. Depending upon the type of the constructions, the seals are also placed at different locations, especially in the case of the linear cylinders or it may be a linear actuators. The different types of seals are the piston seal, piston cups, rod seals and as well as end cap seals. These seals are represented and where it is located that it is shown in the sketch. Now the first one what we are discussing is nothing but the piston seal. The piston seal or the piston ring are used between the piston and the barrel or the cylinder. These rings can be either metallic or non-metallic. That depends upon the temperature. The steel rings are coated with zinc phosphate or it may be a manganese phosphate which gives the life and operation in smooth condition. Especially if the temperature ranges is at low, then the PTFE material or polytetrafluoroethylene materials or indirectly what we can say as a Teflon materials are used as a sealant material. Because of the low coefficient of friction, the ideal and in the pneumatic cylinders and can perform well without a lubrication also. The next one is nothing but a piston cups. In some construction, the piston is provided with a piston cup seal. Compared to the piston with a ring, cup seals are much simpler in design and easy to assemble. They have a L section held in either side of the blank plate. For a single acting cylinder, one cup is used on the pressure side, while for the double acting cylinder two cups are used on either side. The cup are held between the backing plate and as well as the retainer clamp. The leathers or some synthetic materials are used for the sealing cups. Now the rod seals. The rod seals are provided with a three varieties of seals: the dynamic seals, the rod bearing, the rod wipers. Here the materials are also varies. The first one may be a dynamic seal. The synthetic materials it can be used to prevent the leakages of the air. In the case of the rod bearing, the Teflon is used because it should support the rod and also the end cap. The rod wipers, the synthetic materials are used to prevent the entry of the atmospheric contamination. In a very dusty environment, the rubber bellows are also used to protect the cylinder from the dust and other external particles. Now the end cap seals, depending upon the design, either O-ring or the die cut gaskets are used as a sealant material in the end cap and the barrel. The synthetic rubber or the leather is commonly used for this purpose. The seals are used in the cylinders to prevent the losses caused by the leakages and to make the effective use of the compressed air in energy medium. The important characteristics which are required for the seals are the long life, low friction, resistance to heat, stability to foam, higher range of working pressures, higher range of temperatures and also the mechanical strength. These are all the characteristics which are required for a sealant, and these sealants are also a temperature dependent. The next part what we are discussing is nothing but the rotary actuators. As we know that the rotary actuators are used to achieve a angular motion. The rotary actuators are the devices which produces a high torque output and have a limited rotary movement. The standard rotations may be either it may be a 90 degree, 180 degree or 270 degree. The rotary actuators are mainly available in three designs: the vane type limited rotation motors, the single vane rotation motor, double vane rotation motors, the rotary actuators of the rack and pinion type, the helix spine rotary actuators. The first what we are discussing is nothing but a vane type. In this vane type, single vane type rotation motor and as well as the double vane rotation motor. The vane type actuators, where the torque and as well as the motion is all produced by the rotary sense, the construction limits the rotation to the less than one rotation. The piston type actuators are essentially for the linear actuators, that is especially the mechanically connected to translate the linear force, or it may be a linear movement. But if the movement is in the form of a torque, or it may be in the form of a rotation, then we have to go for the vane type of actuators. These devices are capable of providing an output motion of one revolution or more, but not continuous rotations. But both type gives a bidirectional output motions, and most produces the same torque in both the sense. Now, the first what we are discussing is nothing but a single vane limited rotation actuator. The single vane actuator consists of a cylinder housing through which a passes with a central shaft to which a vane is rigidly attached. The housing has a shoe or a stopper fixed to the internal diameter of the housing as shown in the figure, thus dividing the interior space into a two chamber. The pressurized air enter through the port A and rotates the vane in the clockwise direction, and the air in the other chamber moves out through the port B. Similarly, when the air pressure is applied to the port B, the vane rotates in the anti-clockwise direction, and the exhale of the air is from the port A. The design geometry is normally limited to the rotary moment of a single vane actuator is about 280 maximum. The schematic diagram shows the vane actuator which is having a single vane and also a double vane. But here the double vane actuators are also having a major application, that too especially where it is designed to have a two vanes fixed to the output shaft 180 degree apart, and the fixed stoppers in the casting providing a two separate operating halves, each with a two chambers, which is as shown in the figure. This gives a twice the maximum torque output of the single vane device for the same supply of the pressure. Obviously, the maximum angle of the rotation is reduced because of the second stopper. Only 100 is used possibly.